Chapter 7, integration. So we're going to be learning how to integrate standard functions. We're also going to be integrating like functions such as f of ax plus b, and then we're going to be integrating trig identities and reverse chain rule. So, first of all, these are what you should be able to integrate, okay? So we know we increase the power by 1, divide by the new power. So this is just easy integration. And the most important thing, we have to add our constant of integration. Then e to the power of x. We know when we differentiate, it doesn't change. It's the same with integration. E to the x plus c. We know when we differentiate ln of x, we get 1 over x. So when we integrate 1 over x, we're going to get ln over x plus c. Now, we've got the modulus of x because we take the positive. As we know, we reject the negative. When we have cos, remember we have sine minus cos. We're going to go anti-clockwise when we integrate. So we have cos integrates to sine. So we're going to have sine of x plus c. Sine integrates to minus cos of x plus c. Sec squared x, okay? This is one you need to remember. We're going to have a look at why this is true later, okay? And you really need to remember this one. This is tan of x plus c. Cosec x cot x is minus cosec x plus c. Cosec squared x is minus cot x plus c, and sec x tan x is sec x plus c. Now I think all the bottom three are in the formula book, okay? But this is what we should just know straight away, and this is because it's the opposite of differentiation, okay? So, quick fire questions. You should be able to reel these off. We know that the first one is sec x plus c. Sin x integrated is minus cos x plus c. Cosec squared integrated is minus cot x plus c. And minus cos x differentiated is minus sin x plus c. Okay, I suggest you pause the video now and give these a quick go. So, sec squared x dx is tan x plus c. Cosec x cot x integrated minus cosec x plus c. 1 over x integrated, it's ln of the positive, so we're going to write the modulus of x plus c. Minus sin x differentiated is cos of x plus c. Again, pause it, see if you can do these off your head. It'd be really good if you tried to make sure that you memorize all of these. It will just help you so much. Okay, are we ready? Minus cot x plus c. Sin x is minus cos of x plus c. Sec tan, we know, is just sec of x plus c. And cos of x is sin of x plus c. So, very quickly, test your understanding. You know how to do this. Split it all up, and then we always will rewrite it first, and then we'll integrate. Okay, so the only thing I'm going to rewrite is I've got 2 cos x plus 3 over x, okay? I'm going to write that 3 over x as 3 lots of 1 over x minus x to the half with respect to x. Now, if I integrate that, 2 cos x, we know that cos x integrates to sin x, but if you forgot, sin cos minus cos. So, Cos x integrates to sin x, 2 cos x integrates to 2 sin x. 3 lots of 1 over x. We know 1 over x integrates to ln of the modulus of x, so that's going to be 3 lots of ln of x. And then x to the power of a half, increase the power by 1, 3 over 2, divide by the new power, so minus 1 divided by 3 over 2 is minus 2 over 3, and then plus c. So we're going to do the same for the second one. Cos x over sine squared x, I can write this as the integral of cos x over sine x times sine x, okay? With respect to x, I know that, again, this is going to be cos x over sine x times 1 over sine x with respect to x. We actually know that cos x over sine x is 1 over tan x. 1 over sine x is cosec. So cosec. I spelled cosec wrong. I've added an S. Cosec. With respect to x, we know 1 over tan is in fact cot. So I'm going to get cotec cosec x with respect to x. Now we actually know from earlier that we need to memorize this because this equals minus cosec x plus c. Okay, now I probably wouldn't write this whole thing out in the exam, but it's really good to see exactly where all the steps are. Okay, here we have, given that the integral between 3a and a of 2x plus 1 over x dx equals ln of 12, find the exact value of a. Okay then, so first of all, what we're going to do is we need to rewrite this. So we've got the integral between 3a and a, 2x plus 1 over x. I'm going to split this up. So I'm going to get 2x over x plus 1 over x with respect to x. Okay, I know it equals ln 12. We don't have to worry about that for a second. So then the integral between 3a and a, 2x over x is simplified to 2 plus 1 over x with respect to x. Okay, so now I can integrate it. So the integration of 2 is 2x. And we have our limits 3a and a. And the integration of 1 over x is ln the modulus of x. Now what I'm going to do is substitute in 3a. So if I have 3a, I'm going to get 2 lots of 3a plus ln of 3a minus, and then I'm going to substitute in our lower limit, which is a, 2 lots of a plus ln modulus of a. Okay, so then I'm going to get 6a plus ln 3a minus 2a minus ln of a. So now I know this equals the ln of 12, because it tells us that in the question. So now 6a minus 2a. 6a minus 2a, and all we're doing here, again, simplifying algebra. This is the skill we're using for a. Okay, log laws. 3 ln a minus ln a. When we minus, it means divide. So this is the ln. This is plus the ln of 3a over a. Now this, in fact, equals ln 12. Equals ln of 12. So we're going to get 4a plus the ln of 2a equals ln 12. I'm going to minus, sorry, not the ln of 2a. What am I thinking? Ln of 3. so they're going to cancel. So I'm going to get 4a equals ln of 12 minus ln of 3. Now we know when we minus them, it's divide. So 4a equals ln of 12 over 3. 4a equals ln of 4. So to find a, I'm going to divide it by 4. So ln of 4 over 4. This is the exact value of a. Now again, you can see I've done loads of steps here where I'd probably skip them out in the exam just so you understand exactly what's going on. The hardest part of this question is making sure that we split the fraction to integrate it correctly. Okay, please mark your work. So, exercise 7a. Depending how confident you feel, depends how many questions you should do. Really, you need to be aiming to do questions 4, 5, 6 and 7. Okay, if you do need a bit of practice, please go to question 2 and pick 5 from there. Okay? Okay, so skill 2. Integrating the function of ax plus b. So if we were to differentiate sine of 3x plus 1, what we would do is we would differentiate sine of 3x plus 1 using the chain rule, which we know is cos of 3x plus 1, and multiply by the differential of the bracket. The differential of 3x plus 1 is 3. We're going to get 3 cos of 3x plus 1. So, therefore, when we integrate, okay, what we're going to do, if we had cos of 3x plus 1, so we integrate, we're going to get sine of 3x plus 1, and we're going to have plus our constant. But we're actually going to divide by the differential of the bracket, because here we get 3 of it, we only have 1, okay, so we're going to divide. So I'm going to have a third because the differential of 3x plus 1 is 3. So the way I see it is integrate, you normally would divide by the differential of the bracket, for example. And when I mean differential of the bracket is the differential of what we would normally class as x. So these are my brackets here, okay? Sometimes they have a bracket, sometimes they don't have a bracket. So, first of all, e to the power of 3x integrated is e to the power of 3x divided by the differentiation of the bracket. So our bracket's 3x, so if I divide by 1 over 3 plus c. If I think about this one, this is 1 over a function x. Okay, so I know it's 1 over 5x plus 2, but this is 1 over a function x. Okay, and we know that 1 over a function x integrates to ln of that function. Okay, so here we're going to have ln of the modulus of 5x plus 2 plus c, and we're going to divide by the differential of the bracket. 5x plus 2 differentiated is 5, divide by that, so it's 1 over 5. The same here, we know that sec squared, and this 2, because it's 2 lots of this, you can bring that 2 out if you want, because it doesn't actually affect it at all. So if we were to bring, because this is a multiple, 2 lots of this, we can bring this 2 out, okay? Or leave it in, either way. But we know sec squared integrates to tan, okay? So we know we're going to have 2 lots of tan of the bracket plus c, divided by the differential of the bracket. 3x minus 2 differentiated is 3. So here we go, 2 over 3. For the next one, we have the bracket. Remember, this is cubed, so what would we do? We'd integrate, so this is something cubed, so we'd increase the power by 1, divide by the new power, okay? But don't forget, we're also then going to divide by the differential of the bracket. 3x plus 4 differentiated is 3. So, what we're going to do is we're going to have 3x plus 4. This is now to the power of 4 over 12. Because we've divided this by the differential of the bracket in this case. A quarter divided by 3 is 12. Okay, the next one, sine of 1 minus 5x. So we integrate this. Oh, don't forget your constant of integration. So sine integrated is cos of the bracket 1 minus 5x plus c, and then we're going to divide by the differential of the bracket. Remember that integrates to negative cos. We're going to divide that by negative 1 over 5. Oh, so that becomes a positive. Great. So that's just 1 over 5 cos of 1 minus 5x. For the second one, we've got 1 over 3 lots of a number squared. Now, think about this, okay? Imagine this was 1 over 3x squared. We would say this is 1 over 3x to the minus 2. Increase the power by 1, minus 1, divide by the new power. So we get minus a third x to the minus 1. So we know we're going to get minus a third of our x, which in this case is 4x minus 2, to the power of minus 1. But we also need to divide by the differential of the bracket. 4x minus 2 differentiated is 4. So minus a third divided by 4, this is now going to become 12. And our constant of integration c. And then for the second one, imagine, so we've got our bracket, 10x plus 11, integrate it, increase the power by 1, 13, divide by the new power, 13, plus c. But because we've got this bracket, we need to divide it as well by the differential of the bracket. 10x plus 11 differentiated is 10, so we're actually dividing it by 130. So, quickly pause this to check your understanding, okay? So check what's going on. So for the first one, we should have e to the 3x plus 1 plus c divided by the differential of the bracket. The differentiation of 3x plus 1 is a third. For the second one, we have 1 over 1 minus 2x. So we just have x on its own. We know it's going to be a ln of the modulus of 1 minus 2x. We're going to divide by the differential of the bracket. In this case, our differential, 1 minus 2x differentiated is minus 2, so we're going to divide by minus 2, so that's minus a half. For the second one, we're going to have 4 minus 3x, increase the power by 1, 6, divide it by 6, plus c. But then we also need to divide by the differential of the bracket, so a 6 divided by minus 3. This is going to become minus 18. It's going to be minus 18, or you could write it as minus 1 over 18. Lots of 4 minus 3x to the power of 6 plus c. And then the last one, sec of 3x and tan of 3x. Okay, we know that that integrates to sec of 3x plus c, and the differential of the bracket, in our case the bracket is 3, so we're going to divide by 3. Now this only works if they both have a 3x. Okay, they both have to have 3x here. If one had a 3x and one had a 2x, we're looking at something completely different, okay? So, I hope that was all okay. If you are feeling good, please can you do question 5, 6, and 7? If you need a little bit more practice, can you do question 4? And question 2. Just pick a few from each of those, please. Okay, that's on page 150, by the way. Brilliant. Okay, integrating using trig identities. So, we know that sometimes we don't know. Sine squared x, we're not really sure how to integrate that yet in pure 3, other than by using a trig identity. So you need to get that sheet in front of you. Okay, I think it was page 71. You know, we love it. So, sine squared x. What trig identity do I know that has sine squared x? Okay, sine squared plus cos squared equals 1, but we don't know how to integrate a squared function yet of sine squared or cos squared. So the identity I do know is a double angle formula. I know that cos of 2x equals 1 minus 2 sine squared x. So that means that sine squared x equals a half minus a half cos of 2x. So if I integrate sine squared x, I'm going to substitute in a half minus a half cos of 2x with respect to x, because I know I can integrate this. A half integrated is a half x, minus a half cos 2x integrated. Well, first of all, minus cos integrated is sine of 2x, minus a half, and then divide that by the differential of the bracket. Differential of 2x is 2, so it's minus a quarter plus c. For the next question, we have sine of 3x and cos of 3x with respect to x. Okay. This is again a double angle formula, because sine of 2a equals 2, which is 2 sine of a cos of a. So in this case our a is 3x, so sine 2 lots of 3x is going to be sine of 6x is what we're going to actually differentiate to. And remember, it's 2 lots of that, we only have 1 lot, so we're going to have to do a half sine of 6x, which we know when we integrate this, sine of 6x integrates to minus cos of 6x, and obviously this is minus a half, but then we also need to divide it minus a half by 6, because it's divided by the differential of the bracket, which in this case actually minus 1 over 12, plus c. So we need to find the integral of cos squared x dx. Now, cos squared we're not sure how to integrate, but what we do know is that cos of 2x equals 2 cos squared x minus 1. Okay? So that means that cos of 2x plus 1 equals 2 cos squared x. And then obviously if we divide everything by 2, so we're going to get a half cos of 2x plus a half equals cos squared x. So instead of integrating cos squared x, because we're not sure how to do that yet, okay, in pure free, we don't know how to do that, we need to rearrange it using a trig identity, and now we're going to integrate this. So now we want to integrate a half cos of 2x plus a half with respect to x. Now we know we have sine, cos, minus sine, minus cos. If we integrate cos, we're going this way to get sine. Okay? So we have a half sine of 2x. Now, this is where it's like reverse chain rule. This 2x, now, what we did when we differentiated, we multiplied by the differential of the bracket. When we integrate, we're going to divide by the differential of the bracket. So we're going to divide by 2. A half integrated, we know, is a half x. And then, of course, we have our constant of integration, c. So I'm going to simplify this. A half divided by 2. We have a quarter sine 2x plus a half x plus c. Now, if you look at this, if we were to integrate cos squared of x, because we don't know how to do that yet, I'm pretty sure you wouldn't have got this answer here. Okay, so we really need to be on it. Okay. Find the integral of tan squared dx. Now, we know, instead of writing tan squared, what formulas do we know? We do know it's sine over cos, but we don't know how to integrate that yet. Tan squared x, there's a sec involved, isn't it? Okay? So we know 1 plus tan squared x equals sec squared x. Now, you're not given this in the formula book, okay? You really need to remember this. So if we rearrange this, we're going to get tan squared x equals sec squared x minus 1. Now, you can see I always write the identity first. Now we're going to integrate, instead of tan squared x, we're going to integrate sec squared x minus 1 with respect to x, okay? Now, in the formula booklet, it tells you what the integration of sec squared is. It tells you the integration of sec squared is tan, okay? So the integration of sec squared is just tan of x. Obviously, if there was like sec squared 2x, it'd be different, but it tells you this in the formula book. So sec squared integrated is in fact just tan of x. Minus 1 integrated is minus x, and then we have plus c. So this sec squared integrated, it gives you it in the formula book. So it's nice and simple. So these are integrating using trig identities. So I want you to test your understanding, okay? Pause it, give it a go. So we want to find the integration of sec plus tan all squared. Okay, the first thing we're going to do is we're going to expand the bracket, just like we normally would. So we're going to have sec x plus tan x, sec x plus tan x. Okay, I'm going to multiply it all out. I'm going to have sec squared x plus 2 sec x tan x plus tan squared x. So now I'm going to integrate sec squared x plus 2 sec x tan x plus tan squared x with respect to x. Okay. We know the integration of sec squared x is tan x. So for the first part, this one, nice and easy. Okay, this is given to us in the formula book. So we have tan of x. I then have 2 sec x tan x to integrate. Okay? Now, in the formula book, when you differentiate sec of x, you get sec x tan x. Okay? So, working backwards, if you're going to integrate sec x tan x, you're going to end up with sec x. So we're going to have plus 2 lots of sec x. We then have tan squared x to integrate. Now, we've already integrated tan squared x on the previous slide, haven't we? We know that this is, in fact, tan x minus x plus c. So you can see how you can just use facts. So then, second question, find the integral of between pi over 3 and pi over 6 of sine squared 3x dx. Okay, first of all, we don't know how to integrate sine of 3x all squared, so we do need to use a double angle formula. If we've got sine of 3x, what else do we know? It must be cos of 6x. You know, we have cos of 2a equals 1 minus 2 sine of a squared. Okay, this is the rule that we're going to apply right now. In this case, our a is 3x, isn't it? So then we're going to have cos of 2 lots of 3x, which is 6x, equals 1 minus 2 lots of sine squared of 3x. I need to rearrange this to get sine squared of 3x on its own, so then we could use substitution. This is actually going to be sine squared of 3x equals, if I move that to the other side, we're going to get minus a half cos of 6x plus a half. Okay? Now, we're going to integrate this. So the integral is going to be between pi over 3 and pi over 6 of minus a half cos of 6x plus a half with respect to x. So the integration of cos minus a half cos 6x. We know if we integrate minus cos, sine, cos, minus sine, minus cos. If we integrate minus cos, we're going to get minus sine, okay? And then we have to divide by the differential of the bracket. In this case, our bracket is 6x. So if we differentiate that, we get 6. We need to divide by that. So I'm going to end up with minus a half divided by 6. Minus 1 over 12 sine of 6x. A half integrated is, in fact, a half x. And if I put these in square brackets, I don't need to put plus c because we're now going to substitute in our values of pi over 3 and pi over 6. So we're now going to substitute in pi over 3 and then we'll substitute in minus pi over 6. So we're going to have the integration, sorry, not the integration, we're going to have minus 1 over 12 sine lots of 6 lots of pi over 3 plus a half lots of pi over 3. We're going to minus, this is pi over 3, the substitution when we substitute in pi over 6. So we're going to get minus 1 over 12, lots of sine, lots of 6, lots of pi over 6, plus a half lots of pi over 6. Then we know that's going to give me minus 1 over 12, pi over 3 times 6 is sine of 2 pi, plus pi over 6, because a half times pi over 3. Then I'm going to minus 1 over 12, sine lots of 6 times pi over 6 is just pi, sine of pi, plus pi over 12. Now, we know that sine of 2 pi is, in fact, so minus 1 over 12 times sine of 2 pi is 0, plus pi over 6. Sine of pi is 1. No, it's not. It's 0. So then we're going to get minus pi over 12. Pi over 6 minus pi over 12 is actually pi over 12. So that's the final answer. There we go. Okay, so exercise 7C, I suggest you do the questions. Three, 5, 6, 7. Questions 3, 5, 6, and 7. Okay, skill number 4, reverse chain rule. So, reverse chain rule. We're going to do the reverse and then think what could it be, okay? So, the way I like to do this is I like to always think what could it be and then compare at the end, okay? The more we do that, the better we'll get at making connections. For example, if I differentiated, what is the biggest thing here? The biggest thing here is this bracket to the power of something, isn't it? Okay, this is my biggest function, and that's what I always go with. Go with your biggest function, okay? So the biggest function is my bracket to the power of 3. What could I have what do I normally do to differentiate to get a power of 3? It has to be a power of 4. So that's what I do. So I'm going to write this. So I always write consider. Okay, consider bracket to the power of 4. Yeah? If I was to differentiate this bracket to the power of 4, dy by dx would equal, so what do? This is a classic chain rule. We bring the power down, 4 bracket, x squared plus 5, we take away 1 from the power. We then multiply by the differential of the bracket. X squared plus 5 differentiated is in fact 2x. So then we'd end up with 8x, x squared plus 5, all cubed. So if we would consider that y equaled this, when we differentiate this function, this is what we get. Okay, now the question says, if we integrate this function, what would we get? Well, this is very similar. The only thing is, here I've multiplied it by 8, and here it's not. So my original, if this gives me 8 lots of this, and I want 1 lots of this, I would need to divide my original consider by 8, so that then when I differentiate, I'd then have to divide it by 8. Imagine now if this had an over 8. Then this would be over 8, and these 8s would cancel, and would go back to the original equation. So the answer is, by using the reverse chain rule, is the integral, oh, sorry, I don't know what happened there. The integral of x squared plus 5, 3, with respect to x, is in fact what we considered, but divided by 8. 1 over 8, x squared plus 5 to the power of 4. This is what we considered. When we differentiated, we did get this, but we've got 8 lots of this, and I want 1 lot. So I need to divide it by 8 to see what's happening. Okay then, so the next question. Consider cos x sine squared x. So which one's got the highest power? Sine squared of x. Now if I was to differentiate to get that, I need to add 1 to the power, don't I? So it's actually sine cubed of x. So I say that. So consider y equals sine cubed of x. So really we'd have sine of x cubed. This is what y equals. When I differentiate this, I've got something cubed. So when I differentiate, I get 3 bracket squared, because we take away, multiply by the differential of the bracket. We know the differential of sine x is cos x. So then we're going to end up with 3 cos of x sine squared of x. Okay? Now, oh, there's one thing I completely forgot in the last one. So when we integrate it, don't forget your plus c. So now what we have is 3 cos x sine squared x, okay? So this is what we consider. That looks very similar. That looks very similar, apart from the fact that I've got 3 lots of it, and I want 1 lot. So what am I going to do with what I considered? Divide it by 3. So my consideration then is going to be, so I know then that the integral of cos x sine squared x dx is actually going to be what I considered, but divided by 3, because I only want 1 lot of it. So I'm going to get a third of sine cubed x plus c. So then, second, we've got the integral of 2x over x squared plus 1. What do we know that when we differentiate gives us over something. It's actually a ln. Okay, and if you think the x squared plus 1 on the denominator, that isn't x squared, that isn't an x plus 1 all squared. Okay, this is 2x over, imagine this is a bracket, x squared plus 1, so this is actually to the power of 1. And remember, if we were to integrate this, we know we're going to get a log. Okay, so we have to work backwards. So consider y equals ln of x squared plus 1. Now, if I was to differentiate this, I know then I'm going to get 1 over the bracket, which is x squared plus 1, multiplied by the differential of the bracket. X squared plus 1 differentiated is 2x. So I'm actually going to get 2x over x squared plus 1. Now, what you notice is that is actually what we have. So we don't need to divide or do anything. So we know then that the integral of 2x over x squared plus 1 with respect to x equals the ln of x squared plus 1 plus our constant of integration, c. So essentially what we're doing, reverse chain rule, is we're working backwards. We're saying, well, what do we differentiate to get to this? And then we match it up and we make it work. The reason why we do this is because at the moment you do not have the skills to do this yet. We will be able to integrate, like the first function, the first question. We will definitely be able to integrate that, and the second one using integration by parts in pure 4. But right now, if you use that, you won't get the method marks because they want you to use reverse chain rule in pure 3. Okay, so then, reverse chain rule again, okay? So we're still doing reverse chain rule. This time, it's about using common sense, okay? So, what we have here is when we have this is a typical question. We know that x cubed plus 1, that essentially is one function together. That's to the power of 1. So we know it's going to be a ln, okay? So when we spot this, we need to consider y equals ln of x cubed plus 1, because that's what our denominator is. If we were to differentiate this, we're going to get 1 over x cubed plus 1 multiplied by the differential of x cubed, which is 3x squared. So I'm going to have 3x squared over x cubed plus 1. Now, you know that this is the same as writing 3 lots of x squared over x cubed plus 1. So we know that that's the same as this. Apart from here, I've got 3 lots. I only want 1 lot. So I need to divide by 3. So then we've got 3 lots of it. We only want 1 lot. So it means I need to divide my original function by 3. So I'm now going to have the integral of x squared over x cubed plus 1 with respect to x is going to give me a third ln x cubed plus 1 plus our constant of integration c. Okay? For the second equation, I've got x multiplied by e to the power of x squared plus 1. So we know with e to the power of our function, we're just going to consider e to the power of our function because the function at the top doesn't change when we differentiate it. So we're going to consider y equals e to the power of x squared plus 1. If I was to differentiate this, I know that I'm going to get e to the power of x squared plus 1 multiplied by the differential of the bracket, which is in fact 2x. So I'm going to have 2x e to the x squared plus 1. If I compare, I've got 2 lots here and I only want 1 lot. So that means I need to halve my original function of y. So that then means that the integral of x e to the x squared plus 1 with respect to x equals a half e to the x squared plus 1 plus c, our constant of integration. Okay, so we need to always make sure that we write consider, and then we have to show this. Okay, we could write therefore. So, quick fire questions. We should be able to do these in our head. Okay, we should get to that stage where we can do this in our head. Now, if we think about the first one, I've got something over, I know I've got a ln. Okay, so I know this is essentially going to be a ln of x4 minus 1. And if I multiply by 4x cubed, well, actually, that is what my numerator is, so I know I just leave it. For my second one, I've got cos x over sin x plus 2. Okay, I know I've got something over a function. This is a ln. Okay, again, so I'm going to have ln of my denominator, sin x plus 2. If I differentiate my sin x plus 2, do I get cos? Absolutely. I don't need to change anything. So plus c. E to the sine of x, well, I know it's going to be e sin x. And then if I differentiated sine of x, I get cos of x, and I multiply by the differential of the bracket. So that's completely correct. For the second one, I've got the bracket, okay? And if you think about it, the highest power here is 7. So really, it needs to be to the power of 8. And if you think, bring the power down, so it should be 8 lots of whatever we have. We've only got 1 lot, so I need to divide it by 8. And multiply by the differential of the bracket. The differential of sin x is cos x, which is what we have, so then we write plus c. Then, x squared bracket x cubed plus 5, all to the power of 7. If we have something to the power of 7, what should it have been? To the power of 8. Then we know we're going to divide by, multiply by the differential. We're going to multiply it by 8, aren't we? And we have to multiply by the differential of the bracket, which is 3x squared. So actually, we're going to have 24 lots of this. I want 1 lot of this, so I need to divide it by 24, and then plus c. Okay, one that you definitely might not be able to do in your head, but you can give it a go. Always rewrite this. So for the last one, we've got x over x squared plus 5, all in bracket, cubed. So this is going to give me x bracket x squared plus 5 to the power of negative 3 with respect to x. When we differentiate, we bring the power down, don't we? So instead of being negative 3, it's a negative 2. Okay, so we consider y equals x squared plus 5 to the negative 2. So bring the power down. Negative 2. And then decrease it. No, because minus 2 decreased by 1 is minus 3. Then multiply by the differential of the bracket, which is 2x. So I'm going to get minus 4x squared. Minus 4x. I've only got positive x. So then my original one, therefore, we're going to have negative 1/4 lots of x squared plus 5 to the power of negative 2 plus c. Watch out with those negatives, okay? So notice when we differentiate sine of 5x, we know that this is the differential of sine of x to the power of 5. So we have our bracket, don't we? So bring down the power 5 sine of x to the power of 4, because we decrease the power by 1, multiplied by the differential of the bracket, which is cos x. So here we have 5 sine to the power of 4x cos of x. However, when we differentiate sec, we know that the differential of sec, so if we differentiate the bracket, we get 5 lots of sec x, bring the power down, multiplied by the differential of the bracket. Now the differential of sec x is sec x tan x. So the actual answer is 5 lots of sec to the power of 5x tan x. So you can see here, the power does not go down. So please keep this in mind. So here when we have sec to the power of 4x tan x, we consider, so let's consider then that y equals sec to the power of 4x. That's what we're going to consider because the power doesn't change. If we differentiate this, we're going to get 4 sec cubed x multiplied by the differential of sec x, which we know is sec x tan x, which is going to give me 4 sec to the power of 4x tan x. Now you can see here, I've got 4 lots of this. I only actually want 1, so I need to divide what I considered by 4. So therefore the integral of sec 4x tan x with respect to x equals 1/4 of sec to the power of 4x plus c. So now what I would like you to do is to test your understanding. Please pause this, give these questions a go, and then press play when you are ready. Okay, so we have sine of x, cos of x plus 1 to the power of 5. The highest power we have here is cos x plus 1 to the power of 5. So I'm going to consider that y equals cos x plus 1 to the power of 6, because we know we're going to have to bring it down. So we then know that dy by dx equals, bring the power down, 6 bracket cos of x plus 1 to the power of 5, multiplied by the differential of the bracket. The differential of cos is negative sine. So I'm going to have negative 6 sine x cos x plus 1 to the power of 5. Now if I compare this with what I've got here, I've got minus 6 lots. I actually want positive 1 lot, so I need to divide my original consider by negative 1/6. So therefore, the integral of sine x cos x plus 1 to the power of 5 with respect to x equals negative 1/6 cos x plus 1 to the power of 6 plus our constant of integration c. Okay, question 2. Cosec squared x, okay, over 2 plus cot x cubed. My cubed here is my highest power. So consider that y equals 2 plus 2 cot x, and this is negative 3. What do I differentiate to get negative 3? It's negative 2. So then my differential is going to be, differentiate the bracket, bring the power down, cot of x, and decrease the power by 1, which gives us negative 3, multiplied by the differential of the bracket. Now, 2 differentiated is nothing. Cot of x differentiated is in fact minus cosec squared x. Now, it gives you this in the formula book as well. So I'm then going to get plus, so 2 lots of 2 plus cot x to the power of minus 3 cosec squared x, which I can rewrite as 2 cosec squared x over 2 plus cot x to the power of 3. So if I have a look at this, I've got 2 lots of this. I actually want 1 lot, so I need to half what I originally considered. So therefore, the integral of cosec squared x over 2 plus cot x all cubed with respect to x equals a half of 2 plus cot x to the power of negative 2 plus our constant of integration, c. Okay, question 3. sec squared 2x over tan x plus 1 with respect to x. So this is going to, we need to consider y equals ln of tan 2x plus 1. Because I can see here, this is to the power of 1, this whole statement. If I differentiate this, dy by dx equals 1 over tan of 2x plus 1 multiplied by the differential of the bracket. Tan of 2x differentiated is 2 sec squared of 2x. Again, this is in the formula book. So I've got 2 sec squared 2x over tan of 2x plus 1. When what I considered, I have two lots. I actually want one lot, so I need to half what I considered as my final answer. So therefore, the integral of sec squared 2x over tan of 2x plus 1 with respect to x equals a half of ln tan 2x plus 1 plus our constant of integration, c. Okay, for the next one, I have a bracket to the power of 3. If I consider what was before this, consider then that y equals the bracket to the power of 4. If I differentiate this, I'm going to get 4 bracket x squared plus 2 to the power of 3 multiplied by the differential of the bracket. The differential of x squared plus 2 is 2x. So I'm going to have 8x bracket x squared plus 2 to the power of 3. If I compare this, I've got one lot here, I've got 8 lots here, so I need to divide what I considered by 8 to get 1. So therefore, the integral of x squared plus 2 all cubed with respect to x is going to equal 1 over 8 x squared plus 2 to the power of 4 plus c. And then finally, we have 5 tan x sec squared x. So I know if I have a sec squared, when I consider, I'm going to consider that y equals sec squared x. The differential of sec squared x is in fact 2 sec x multiplied by differential of sec, which is sec x tan x. So I'm going to have 2 sec squared x tan x. Now again, we know that, and in the formula book, if we differentiate sec x, we get sec x tan x. Okay? And you can see here, though, I have 2 sec squared x tan x, and I want 5. How do I get from 2 to 5? I multiply by 5 over 2. So therefore, the integral of 5 tan x sec squared x with respect to x equals 5 over 2 lots of what I considered, which was sec squared x plus our constant of integration c. Because if I had 5 over 2 here, I'd be multiplying this by 5 over 2, which would give me 5. Okay? So always watch out for that. So then we've tested our understanding now. And always make sure, if you're not sure what you should be integrating and how, have a look in the book of what differentiations they give you on the formula book and the integration book. Okay, so on exercise 7D, please could you do questions 3, 4, 5 and 6. So questions 3, 4, 5 and 6.